Yeah. We're on this one here. So we'll do two more of these here with vertical stretch and shrink and horizontal stretch and shrink so we can kind of remember those there. Now our horizontal translation, I'm just rewriting these back out so we, is our f of x minus h. Vertical translation, f of x plus k. Our reflections, if we're going across the x-axis, it's negative f of x. And if we're going across the y-axis, is f of negative x. Our vertical stretch or shrink is a times f of x, and our horizontal stretch or shrink is f of ax. We have to remember to flip the value. Yep, kick flip. So if they give us a value of, say, a horizontal stretch by a factor of 5, we have to flip it. 1 over 5. Yep. So again, these are just the general forms that we're using to be able to apply the transformations. All right. Now again, these are the general forms. We've been putting these up there. I've been putting them up there each day. You do have them in your notes. But it would be good to write down. Now, especially on the test, I would say this would be something I would find a spot on the review sheet and put them in, just so you have them to reference back. Personally, especially on the review sheet, I would put these right next to the problems that require you to use these transformations. I just wouldn't put them anywhere. I'd put them right next to the problems that need it. Now, we've been working on these the last few days, and the last ones we did were vertical stretch shrink, horizontal stretch shrink. So the first one we're going to look at here, we picked up from yesterday, was to write a function g whose graph represents the indicated transformation of the graph of f. We won't use a graphing calculator. We'll just do this here. So we're wanting to call this g of x. Now, here, we're wanting to apply a vertical shrink by a factor of 1/3. So our vertical stretch or shrink. So here we would not, because it's vertical. The only one we flip is horizontal. Horizontal, flip. Vertical stays the same. So our vertical is a times f of x. Now, part of the reason we have to flip it with horizontal is the general form for horizontal is f of a times x. And we just plug that value of a in. anytime we're inside that parentheses, we're kind of having that take place. Now the question is also, why not with horizontal translation left to right? Yes? That is x minus h. And we've seen, I'll write this out, f of x minus h. If h was to the left 4, negative 4, we plug it in, we get f of x minus negative 4, which is our x plus 4. That switch did occur. We didn't have to do anything to it. If we said h was positive 7, f of x minus 7, that switch has taken place. We didn't have to do anything to it. Now with our f of a times x, and we said a was given to us as 3, let's just plug it in. It would be f of that flip, that kind of opposite didn't take place. That's why we're having to apply it. We're having to flip it because it's not going to be 3x, it's going to be f of 1/3. It has to be applied there because horizontal translation left right, that x minus h took care of that switch, that change. Here, it did not, and that's probably not the purest mathematical description of it, but I think that's the one we can latch on to a little bit easier. Does that kind of make, and again, I would just put an emphasis or just make sure, especially on tests, horizontal, we got to flip it. Now here, since it is vertical, that is kind of nice because the factor, our value of a, not going to change. We don't have to do anything to it. It's still just 1/3. So we can plug that in. Our value of a is 1/3. So that's all that we have for a. Now we still have f of x, yes? All right. We're going to do something a little bit quicker this time. Not so much different, just quicker. Did we mess with f of x at all? No, it's still f of x, right? So we can replace it with its function. Because we can do this one step at a time like we've been doing the other day. I can say 1/3 f of x. And then we can write 1/3 parentheses, absolute value of x minus 3, close parentheses, in 2 separate steps. There is nothing that says I can't replace them both at the same time. If you feel comfortable replacing them both at the same time, replace them both. Put them both in. If not, do one, then the other. Do a and then f of x. Because the last thing we need to do is distribute the 1/3. Yes, we cannot distribute the 1/3 into the absolute value. We can't multiply it in and have absolute value bar 1/3 x. So the 1/3 stays outside. 1/3 absolute value of x minus, now we have to take 1/3 times 3. Well, luckily, in the 30xs, let's go around that. Yeah, 1/3 times 3 is 1, or we could say 1/3 times negative 3, because it is really negative 3, which gives us our minus 1. Questions on this here? Questions on anything we've done so far? We ready for the next one? So we want to write a function g of x. So we're taking f of x here, 4x plus 2, and applying a horizontal stretch by a factor of 2. This is the one where we flip. It might not be. Yep. So I think I left this one off. So I did give you the homework yesterday. Yes. So that's what's next. So guys, this one's not on the note sheets. I do need to fix that. But here, horizontal stretch by a factor of 2. Horizontal stretch by a factor of 2. So yes, we do have to flip it. So if we flip 2, it becomes 1/2. So again, this one's not on the note sheet. I added it back and didn't get it in the note sheet. So we get this here. So A, the value they gave us was 2, but the number we're going to plug in is 1/2. We have to flip it. We have to flip it. 1 over. Now what we have is f of 1/2 x. So we have to go back into the function and replace every x in the function 4x plus 2 with 1/2 x. So we'll have 4 times 1/2 x plus 2. And the only thing we really have to do is, after writing this out, is we do have to multiply the 4 and the 1/2 x. Well, 4 times 1/2 is 2 x plus 2. And that's it. Questions on this here? All right. Let's move on. This is the last thing we're going to be doing. Combining transformations. So when we do these here, we're going to be doing more than one transformation to a function at a time. Now, it seems like this is going to be a lot harder than what we're doing. All we're doing is pretty much what we've been doing, just applying it more than once. So let's look at this one here. Let the graph G be a vertical shrink by a factor of 0.25, followed by a translation 3 units up of the graph f of x equals x. We're doing one at a time. And when we apply the transformations, again, I would highly emphasize doing these one at a time and applying them in the order that they are listed. So it might be tempting to, well, up 3 is a nice one to do first. Do it, and then the vertical stretch or shrink. Again, order of this matters when we apply it. So the first thing we want to do is apply the vertical shrink. Now, f of x is the function we're starting with. This is the one we're applying it to at first. Now again, f of x, g of x, h of x, these are just ways to name it. Now the problem wants us to name the final problem g of x, yes? Well, we have a few steps in between. So I'm going to name it something else. I just picked h because that's what we've been using. So h of x is going to be the middle step, and then at the end we'll call it the last one, g. Now h of x is going to be our one that we're applying, using to apply the vertical shrink. So vertical shrink, our general form is a times f of x. Vertical stretch or shrink, a times f of x, where a is the amount that we're stretching or shrinking the function by. Now for this here, our a value is going to be 0.25, 0.25. Well, our next step is, bless you, is we will plug the 0.25 in for a. And since this first one we're doing, I'm just going to write it out as 0.25 times our f of x. Bless you. And now at this point, we will replace f of x with its function, which is just x. Questions on this here? All right, guys. Let's bring it back in. So we'll need to multiply these two out. 0.25 x. Questions on this here? Vertical shrink by a factor of 0.25. Done. 3 units up. So now we're going to do translation 3 units up, and that is the last transformation, yes? So the next one we can call it is G of x, because that's what they wanted to be named. Now, I'm not going to be a nitpick on the name. If you finish with f of x, g of x, h of x, q of x, I'm more focused on the function. So g of x equals. So we're talking about a translation up our vertical translation, yes? And the general form for it was f of x plus k, yes? Our k would be 3, but we're not applying it to f of x anymore. What are we applying it to? For us, we named it what? We can say g of x is equal to h of x plus k. Yeah. Okay.
So then we put g of x equals 0.5x plus 3.
Yes. So again, f of x in all of our general forms is just the function. F is the one we're applying it to. Since we're not applying it to f anymore, we're applying it to h. We have h of x plus k. Now our k value would be positive 3 since we're going up. And we could write it out as h of x. Then we would replace h of x with its function, which would be 0.25 x plus 3. We can't simplify anymore. They are not like terms. Even though we don't have absolute values, they're still not like terms. And that's it. So no matter how many transformations we do or what they are, we're doing the same steps in the same process as we did for doing one each function. We're just doing it one at a time. Are you ready for the next one? Let the graph G be a translation 6 units down, followed by a reflection in the x-axis. And then we'll write a rule for G. So the first thing we're going to do is 6 units down, and then we're going to reflect it in the x-axis. So I'll call the first one h of x. So translation of 6 units down, again, vertical translation. So we're taking our f of x, because we're still applying it to f of x at this point, plus k. Now our k value is 6, and it would be negative. We're good?
The wording's different on this one. On slide. It doesn't have. So I was like, that was different.
Yeah, this is, yeah, it is the same. It's just the number 7's cut off. Yes. So questions on this so far? So we're good with finding the value of k, yes? Because k is negative 6 since we're going down 6. We can plug it in. Now we can plug in f of x. It's going to be our absolute value of 6. Now again, we could put parentheses around the f of x, but there's nothing in front of it. So we don't necessarily need it. Right, because there is nothing wrong with putting the parentheses around it. But since we have nothing to apply to it, we would drop the parentheses. Because especially if we're plugging it into something, so our horizontal translation left to right, our horizontal stretch and shrink, our reflection across the x-axis, y-axis, and vertical, where we're having to apply something through the function, the parentheses are necessary. Here, we end up sticking something onto the end. But questions on how we applied the first transformation. So our translation of 6 units down is done. Now we have a reflection in the x-axis. Yep. Yes. And since this is the last one, we could call it g of x. Negative. So this here, this reflection in the x-axis, we're applying to h of x, because it's the one that we just did. So we're not applying it back to the original function. F of x is the absolute value of x. We're applying it to the one that we moved down 6. Now at this point here, we can replace h of x with its function. Now this one here, we definitely need the parentheses because we do have something in front of that h of x, something that has to be applied to the whole thing. Yes. So the negative is going to be applied to the absolute value, which would give us negative absolute value of x. And then the negative will be applied to the 6, turning it into a 6. And that's it. Because with any of these here, no matter how many we apply or add, we're just doing one transformation at a time and then applying the next transformation to the result we got from the previous one. Questions on this here? Would you feel comfortable with these here? Uh, 20 minutes.